guys. So this is an extra credit topic. It's topic UKG. And I'm not expecting all of you to finish it, but if you want to try it, I'm going to give you a couple example problems. But this is the formula for growth, exponential growth, and this is the formula for exponential decay. And you'll notice that I have this labeled here with growth factor, growth rate versus decay factor and decay rate. I would say this part in blue is what makes this whole thing a little bit confusing. You're either going to be in a word problem. So like if you're looking at the example that I have on the share screen here, you're going to have some kind of word problem, and it's going to be either a growth problem or decay problem. So you have to decide which one is which first. But then you have to decide whether they're giving you the growth information or decay information as a factor or as a rate. And this was the part that very much confused me when I was in school, and even explaining it to students has taken some practice. So we'll go through a few examples to explain it. But one of the ideas is that if they're giving you a percentage, then you know that's a rate. Whereas if they're saying something is like twice as much or a half-life or some kind of like amount that seems like a multiplication problem, that's a factor. Okay, Zane's playing a video game which he establishes and builds up a city, and the population of this city is currently 42,000 people. So first things first, A, in both situations, is the initial amount. So this is true for both sides here. And so in this situation, for this example, I already know this is going to be a growth situation because it talks about how the population's increasing. So it means it's getting bigger, obviously. So I'm going to put the example on this side under growth, but it's telling me it's 10%. And then it's telling me that the starting amount there is 42,000 people. So A equals 42,000, right? And then it says it increases by 10%. So that is the growth rate. This is the percentage. So R equals 10%, which we can't just write an equation with a percentage sign. We have to change that into a decimal. So it's 0.10. Hopefully that seems like something you remember from previous years. And so when I say here 1 plus the rate, then really inside this equation, what I'm trying to figure out, which we call B, so this whole thing really is called B, is the growth factor. B is 1 plus 0.10. So 1.1. So when I'm plugging into my equation, really what I'm saying is y equals a times b to the x power. And so a is going to be 42,000. B is going to be what I got when I add this to 1. So I got 1.1. So now this is the growth factor. So this is growing by 10%, which could also be described as multiplying by 1.1, which is what the difference is here. This is described as a percentage. This is described as a multiplication problem, but both of them are the same idea. You just have to add 1 to go to the growth factor. And then in the problem, it's asking you, what will the population be in 16 years? So the last part of this is X, and X is time. Mostly in years, but not always. So if I'm saying 16 years, so X equals 16 for this problem, I'm basically plugging in 16 there. And then this is just a math problem. I'm just typing this in, 42,000 times 1.1 to the 16th power. So it says 192. 988. Round to the nearest whole number, which I guess in this case would be 9. So let's make sure that works. 192. Yeah, good job. All right, hopefully. So this is also increases. So this one is also a growth problem. So let's do another one of these. So example, A equals And it says it starts with 39,000. And then how much will be published 7 years later? So I want to know when x equals 7 would happen. So I got to figure out is that R and B part in the middle. So R is 5%, which is 0.05. And so that means B is 1 plus R. So 1 plus 0.5, 0.05 equals 1.05. So this is B, this is A, and this is X. So I'm just plugging those into Y equals A, B to the X power. So 39,000 times 1.05 to the 7. So 54,877 if I round to the nearest whole number like it says. So this will be the same kind of thing, another increase, right? Because it's a savings account, so it's getting bigger, it's increasing. So y equals a to the b, or a times b to the x power. And so it starts with $90. So y equals $90, right? And then she's earning 5%, which means that b is going to be 1 plus 0.05. And they want to know how much she'll have after 3 years. $104 to the nearest cent. So make sure you're reading the instructions. So that'd be 19 cents. Oh, duh, Miss Gray. So this is the amount she had in the account, but it's not the amount of interest. So again, make sure you read the question carefully. I wish we were in class together because you'd be finding that I do this at least once a day. So if it's asking how much interest she will earn, then basically she started at $90, right? So her initial amount was 90. And then after they added interest for 3 years, she had 104.19. So we have to subtract those to figure out what the actual interest is. So this was her starting amount. This is her ending amount. And we want to see how much she earned in interest by subtracting interest. So this would be 19, and then sorry, my son's in the background talking. So it's very distracting. Basically, she earned, if you're just thinking about what happens with 104.19 minus $90, that means basically she earned $14.19, right? And that's what it's saying there. So if we go down to the bottom, 14.19. So just don't forget to read the instructions. So you're not trying to find the total she had, but it was actually trying to find just the interest that she earned on top of that. Okay, got it. I'm trying to find one that has a decrease. So that's growing again. Growing. They're all growing. Well, Seems like all these problems are all at a growth rate for some reason. So hopefully it'll be the same on your end also. You'll just run into a bunch of growth problems and you'll be able to go through. Okay. Let me know if you have questions. You can always ask me, or we can always work out some together. Okay, good luck.